Let's continue with our discussion on highway and railroad engineering. Now, today we have our topic, passing sight distance on a level road surface. Passing sight distance is defined as the sight distance long enough to enable a vehicle to overtake and pass another vehicle on a two-lane highway without interference from opposing traffic. And for the total passing sight distance, we have S equal to D1 plus D2 plus D3 as D4. Now, what are those D1, D2, D3, and D4? Okay. Now, D1 is the distance traversed during perception and reaction time and during the initial acceleration to the point of encroachment on the left lane. So in the figure, we have this D1 here. So this is our vehicle, the blue one. So D1 is the distance traversed during perception and reaction time. So as the vehicle is traveling, it will traverse a distance of D1 while thinking of overtaking. So this is your D1. Whereas this yellow here, this yellow vehicle is the one to be overtaken. Now D2 is defined as distance traveled while the passing vehicle occupies the left lane. So our blue vehicle here will occupy the left lane, and the distance from where it occupied the left lane towards where it will move to its lane again. So the blue vehicle moves here, and then from here, this point, then it goes back to its original lane. So the distance traveled there is the D2. Okay, so it overtakes the yellow vehicle. So of course, while the blue vehicle there is moving, the yellow vehicle is moving also. So from this point to that point. That's why it took D2 distance for the blue vehicle to get back to its original lane. Now D3 is the distance between the passing vehicle at the end of its maneuver. So it's talking about the end of D2 and the opposing vehicle. So it is the distance between the passing vehicle at the end of its maneuver and the opposing vehicle. It's talking about the distance between the blue vehicle and the incoming red vehicle here. So the distance is D3. Okay. Upon the blue vehicle successfully returning to its original lane, it is the distance that is between the opposing direction of the vehicle. Now D4 is the distance traversed by opposing vehicle for 2/3 of the time the passing vehicle occupies the left lane, or sometimes taken as 2/3 of D2. So the red vehicle here, while the blue vehicle is doing its maneuver, this is the distance traveled by the red vehicle. It's the D4. Okay? And it is considered as the 2/3 of D2. Okay? So this is our analysis of the passing sight distance. Now let's solve for the sample problems. So we have here sample problem number 1. Compute the passing sight distance that vehicle A could move while overtaking the slow-moving vehicle B before meeting this oncoming vehicle C. So the figure is this one. So the one to overtake is the vehicle A. Of course, this is your vehicle A. Then the slow moving vehicle is vehicle B. And this oncoming vehicle is vehicle C. Okay. It should be C. Okay. Then, given the speed of car A as 96 kilometers per hour, perception reaction time equals 2.5 seconds. Average acceleration of 2.4 meter per second squared. The time the passing vehicle occupies the left lane is 10.4 seconds. And the distance between the passing vehicle at the end of its maneuver and the opposing vehicle is 84 meters. Now we will be computing the passing side distance. So we are to solve this. So PSD, or passing side distance, is equal to distance 1 plus distance 2 plus distance 3 plus distance 4. Now first, let's convert the velocity of vehicle A. So vehicle A is the speed of the overtaking vehicle. This is 96. Alright, let's put it here first. Speed of overtaking vehicle. Now VB is the speed of slow moving vehicle. Okay. Now let's convert. For VA is equal to 96 kilometers per hour, and that is 1 hour 3,600 seconds. Then we have 1,000 meter in every 1 kilometer. That is equal to 26.67 meters per second. Now for the vehicle B, it's not written here, but actually vehicle B the original problem is here. The speed of car B is 88 kilometers per hour. Okay, now for velocity B, which is 88 kilometers per hour, you can just divide it with 3.6. Then we get the value of 24.44 meters per second. Okay. Now let's compute for the value of D1, or the distance where the driver is having a perception reaction time. Okay. The distance traveled during perception and reaction time. Now, we need to consider that at the moment, driver decides to overtake, its velocity is equal to the velocity of the slow moving vehicle. So yes, it's behind the slow moving vehicle, so that's why its velocity is the same with the slow moving vehicle. So for D1, we have their velocity. Let's use the velocity of the slow moving vehicle, the time, the perception time, plus 1/2 of the acceleration times the time. VB is 24.44 times the perception time is 2.5 seconds plus 1/2 of the acceleration of their acceleration 2.4 meter per second squared. Then the time of 2.5 seconds. Now D1 is now equal to D1 is equal to 68.6 meters. Okay. Now how about for D2? Remember that for D2 is the distance traveled while the passing vehicle occupies the left lane. So what do you think is the speed of the vehicle A, or the blue vehicle? What do you think is the speed of the vehicle while it's in the left lane, or while it is overtaking? Yes, that is 96 kilometers per hour, or it is 26.67 meter per second. Now for D2, we have their velocity A times time where it is in the left lane. So VA is 26.67 times what is T2, or its time while it is occupying the left lane. It's 10.4 seconds. And that is equal to, okay, so 277.37 meters. Now D3, what is D3? D3 is the distance between the passing vehicle at the end of its maneuver and the opposing vehicle. So this part here. So we need to find what's this D3. Actually, it's given in the problem. Distance between the passing vehicle at the end of its maneuver and the opposing vehicle is equal to 84 meters. So therefore, D3 is equal to 84 meters. Now D4 is the distance traversed by the opposing vehicle for 2/3 of the time the passing vehicle occupies the left lane. So it's this portion here. So D4 is 2/3 of D2, 2/3 of 277.37. So D4 is equal to 184.91 meters. Therefore, your passing sight distance, or S, is equal to D1. There's D1 at 68.6 plus D2 277.37 plus D3 of 84 plus D4 is 184.91. So passing site distance is now equal to 614.88 meters. So that's the distance you should allot before overtaking a vehicle with the velocity of 88 kilometers per hour. And if you are using a velocity of 96 kilometers per hour as you are overtaking. Okay, let's go to the example number 2. This time, it is asking for the minimum passing site distance for the following data. Speed of the passing car is 90 kilometers per hour. The speed of the overtaken vehicle is 80 kilometers per hour. Time of initial maneuver is 4 seconds. Average acceleration is 2.4 meter per second squared. Time passing vehicle occupies the left lane, 9 seconds. Distance between the passing vehicle at the end of its maneuver and the opposing vehicle is 80 meters. So we are computing for the minimum passing site distance. Now, if we go back to the discussion here, you can observe that it's already given the minimum passing site distance. For the minimum passing site distance, it is between point A. Okay, so it is between point A to point B. It is when the passing vehicle is occupying the left lane and then towards the distance of the incoming vehicle. So that is the minimum passing site distance. So let's compute for that. Let's compute for this portion. Minimum passing site distance is equal to, if you observe, we have there 2/3 of D2 plus D3 plus D4. But if we recall, D4 is equal to 2/3 of D2. Therefore, minimum passing site distance is equal to 4/3 of D2 plus D3. So we will compute for the D2 only. Why? Because D3 is already given. So D3 is this. And we still have to solve for D2. Now D2 is the distance when the vehicle is on the left lane. So D2 is velocity of the overtaking vehicle times time while it is in the left lane. We have there convert first for VA. So VA here is 90. It's the faster vehicle because it's overtaking. So 90 kilometers per hour. Divided by 3.6 That is equal to 25 meters per second. So D2 now is equal to VA 25 times time, says there, time passing vehicle occupies the left lane, 9 seconds. So 25 times 9 is equal to 225 meters. Therefore, minimum passing sight distance is equal to 4/3 of D2 or 225 plus 80. That is equal to 380 meters. Okay. Okay, that's all for passing sight distance on horizontal road.